Good morning to everyone. I am Parkavi, working as Assistant Professor of Mathematics in Erode Sengundar Engineering College. Now we discuss about Lagrange's interpolation formula for unequal intervals. Lagrange's interpolation formula discuss in equal intervals and also unequal intervals. Equal intervals means x varies from 2, 4, 6, 8. The difference is common, that means 2. So the intervals is called equal intervals. In case x is x from 1, 3, 7, 4, that means the difference is not measured. So the intervals are called unequal intervals. Now we see unequal intervals. The formula for Lagrange's interpolation formula is y is equal to f of x is equal to x minus x1, x minus x2, etc. x minus xn divided by x minus x1, x naught minus x2, etc. x naught minus xn into y naught plus x minus x naught, x minus x2, etc. x minus xn divided by x1 minus x naught, x1 minus x2, etc. x1 minus x naught into y1 plus etc. plus x minus x naught, x minus x1, etc. x minus xn minus 1 divided by xn minus x naught, xn minus x1, etc. xn minus xn minus 1 into yn. This is the formula. Now we have to see the problem. Using Lagrange's interpolation formula, find y of 10 from the following table. Y of 10 means we find the we substitute x is equal to 10 value. X varies from 5, 6, 9, 11 and y varies from 12, 13, 14, 16. We use the Lagrange's interpolation formula. Y is equal to f of x is equal to x minus x1, x minus x2, x minus x3 divided by x naught minus x1, x naught minus x2, x naught minus x3 into y naught plus x minus x naught, x minus x2, x minus x3 divided by x1 minus x naught, x1 minus x2, x1 minus x3 into y1 plus x minus x naught, x minus x1, x minus x3 divided by x2 minus x naught, x2 minus x1, x2 minus x3 into y2 plus x minus x naught, x minus x1, x minus x2 divided by x3 minus x naught, x3 minus x1, x3 minus x2 into y3. Here x varies from x2, that means x naught to x3, and y varies from y naught to y3. So now we substitute the value of x naught, x1, x2, x3. x1 value is 5, x naught value is 5, x1 is 6, x2 is 9 and x3 is 11. Also y naught is 12 and y1 is 13, y2 is 14 and y3 is 16. Now we substitute the value, we get x minus 6 into x minus 9 into x minus 11 divided by 5 minus 6 into 5 minus 9 into 5 minus 11 into 12 plus x minus 5 into x minus 9 into x minus 11 divided by 6 minus 5, 6 minus 9, 6 minus 11 into 13 plus x minus 5, x minus 6, x minus 11 divided by 9 minus 5, 9 minus 6 into 9 minus 11 into y2 value is 14 plus x minus 5, x minus 6, x minus 9 divided by 11 minus 5, 11 minus 6, 11 minus 9 into y3 value. Y3 value is 14. So into 14. So now we substitute x is equal to 10, we get that means 10 minus 5, 4, that means 10 minus 5, 10 minus 5, 5, 10 minus 6, 4 into 10 minus 11 minus 1 divided by 9 minus 5 minus 1, 9 minus 5 minus 4, 9 minus 6 minus 3, 9 minus 11 minus 6 into 12 plus 10 minus 5, 5 and 10 minus 9, 1, 10 minus 11 minus 1 divided by 6 minus 5, 1, 6 minus 9 minus 3 and 6 minus 11 minus 5 into 13 plus 10 minus 5, 5, 10 minus 6, 4, 10 minus 11 minus 1 divided by 9 minus 5, 4, 9 minus 6, 3, 9 minus 11 minus 2 into 14 plus 10 minus 5, 5, 10 minus 6, 4, 10 minus 9, 1 divided by 11 minus 5, 6, 11 minus 6, 5. So 11 minus 9, 2 into 16. We solve the equation, we get 14.666. Next problem, find the parabola of the form is equal to ax squared plus bx plus c passing through the points 0, 0, 1, 1 and 2, 20. Here x0 value is 0 and x1 is 1, x2 is 2 and y0 is 0, y1 is 1 and y2 is 20. We apply the Lagrange's interpolation formula. The formula is y is equal to f of x is equal to x minus x1. Here x varies from x0, x1, x2. So x0 to x2. We stop the formula from x2. And also y varies from y0, y1, y2. So we stop the formula for y2. So we get x minus x1, x minus x2 divided by x0 minus x1 into x0 minus x2 into y0 plus x minus x0, x minus x2 divided by x1 minus x0, x1 minus x2 into y1 plus x minus x0, x minus x1 divided by x2 minus x0, x2 minus x1 into y2. Here x1 value is 1, so x minus 1, x2 is 2, so x minus 2 divided by x0 is 0, so 0 minus 1 minus 1 and also 0 minus 2 into y0 value is 0 plus x minus x0, so x minus 0 x minus x2 means x minus 2 divided by x1 minus x0, so 1 minus 0 1 and x1 minus x2, so 1 minus 2 is minus 1 into y1 value is 1 plus x minus x0, so x minus 0 next x minus x1, so x minus 1 divided by x2 minus x0, so 2 minus 0 2 also x2 minus x1, so 2 minus 1 1 into y2 is 20. So the first value is 0, we multiply 0 we get 0 and the next one is minus x into x minus 2 plus 10 into 10 2s are 20, so cancel, we get 10 into x minus 1, we multiply x in, we get minus x square plus 2x plus 10x square minus 10x. So we simplify the equation, we get y is equal to 9x square minus 8x. And the next problem, using Lagrange's formula of interpolation, find x values varies from minus 1, 0, 2, 3 and y varies from minus 8, 3, 1, 12. So here y of x is equal to 2x cube minus 6x squared. We apply the Lagrange's interpolation formula. We get y of x is 2x cube minus 6x squared plus 3x plus 3. So we find y of 1. So we put x is equal to 1 in the equation. We get 2 minus 6 plus 3 plus 3. So 6 minus 6 0. So we get y of x is equal to 1 is equal to 2. Next, Newton's divided difference formula. Let the function y is equal to f of x. Assume the values f of x0, f of x1, etc. f of xn corresponding to the arguments. And the function f of x, f of x0, f of x1, f of xn. The corresponding functions are x0, x1, etc. xn. Where the interval x1 minus x0, x2 minus x1, etc. xn minus 1. The intervals are need not be equal because the Newton's divided difference formula used in unequal intervals. Newton's interpolation formula for unequal intervals are Newton divided difference formula. Let y is equal to f of x. Take values f of x0, f of x1, etc. f of xn corresponding to the arguments x0, x1, etc. xn. By definition, f of x, x0 is equal to f of x minus f of x0 divided by x minus x0. So the formula for Newton divided difference, f of x is equal to f of x0 plus x minus x0, f of x0, x1 plus x minus x0, x minus x1, f of x0, x1, x2 plus etc. plus x minus x0, x minus x1, etc. x minus xn minus 1 into f of x0, x1, xn. Now we see the problem. Using Newton's divided difference formula, find the value of f of 2, f of 8 and f of 15. given the following table, and x values varies from 4, 5, 7, 10, 11, 13, and corresponding f of x value is 48, 100, 294, 900, 1210, 2028. So first we form a Newton divided difference table. We write the corresponding x values and also f of x values. Now we find del f of x. Del f of x means a difference between the second value minus first value divided by second value minus first value. That means second value minus first value of f of x divided by second value minus first value of x value. So we get 100 minus 48 divided by 5 minus 4 is equal to 52, and also 294 minus 100 divided by 7 minus 5 is equal to 97, and 900 minus 294 divided by 10 minus 7 is equal to 202. 1210 minus 900 divided by 11 minus 10 is equal to 310. 2028 minus 1210 divided by 13 minus 11 is equal to 409. So next we form del squared f of x. Del squared f of x is the first value minus second value minus first value of del f of x divided by third value minus first value of x function. So we get 97 minus 52 divided by 7 minus 4 is equal to 15. 202 minus 97 divided by 10 minus 5 is equal to 21. 310 minus 202 divided by 11 minus 7 is equal to 27. 409 minus 310 divided by 13 minus 10 is equal to 33. Next we form del cube f of x. So the del cube f of x is the difference of second value minus first value of del squared f of x divided by fourth value minus first value of x function. So we get 21 minus 51 divided by 10 minus 4 is equal to 1, and 27 minus 21 divided by 11 minus 5 is equal to 1, and 33 minus 27 divided by 13 minus 7 is equal to 1. Next we calculate del power 4 of f of x. So 1 minus 1 we get 0. So the value of del power 4 f of x is 0. Now we use the divided difference interpolation formula. F of x is equal to f of x naught plus x minus x naught into f of x naught comma x1 plus x minus x1 into f of x naught comma x1 comma x2 plus x minus x0 x minus x1 x minus x2 into f of x naught comma x1 comma x2 comma x3 plus etc. Here the value of x0 is 4 and x1 is 5, x2 is 7 and x3 is 10 and x4 is equal to 11, x5 is equal to 13, and the corresponding value of f of x0. F of x0 is the value of del f of x of the first value. So the f of x0 value is 48 and f of x0 comma x1 is equal to 52, and f of x0 comma x1 comma x2 is equal to 15, and f of x0 x1 x2 x3 is equal to 1. Now we substitute the values in the formula for Newton's divided interpolation. We get f of x is equal to 48 plus x minus 4 into 52 plus x minus 4 x minus 5 into 15 plus x minus 4 x minus 5 x minus 7 into 1. So now we substitute, now we find the value of f of 2, f of 8, f of 15. So we substitute x is equal to 2. We get f of 2 is equal to 48 minus 104 plus 90 minus 30 is equal to 4. So the f of 2 value is 4. Next we calculate f of 8. So substitute x is equal to 8. We get 48 plus 4 into 52 plus 4 into 3 into 15 plus 4 into 3 into 1. So we get 448. Next we calculate f of 15. So substitute x is equal to 15. We get 48 plus 11 into 52 plus 11 into 10 into 15 plus 11 into 10 into 8. So we get the value of f of 15 is 3150. And then second problem, from the following table find f of x and hence f of 6 using Newton's interpolation formula. Here the x values varies from 1 to 7, 8 and corresponding f of x value is 1, 5, 5, 4. So evidently intervals are not equal, so we form the divided difference interpolation table. First we form a table. x value is 1278 and f of x 1554. First we calculate del f of x. Del f of x means second value minus first value of the function divided by second value minus first value of x. So we get 5 minus 1 divided by 2 minus 1 is equal to 4, and 5 minus 5 divided by 7 minus 2 is equal to 0. 4 minus 5 divided by 8 minus 7 is equal to minus 1. Next calculate del squared f of x. We get 0 minus 4 divided by 7 minus 1 is equal to minus 2 by 3, and say minus 1 minus 0 divided by 8 minus 2 is equal to minus 1 by 6. So we find del cube f of x minus 1 by 6 plus 2 by 3 divided by 8 minus 1. So we get 1 by 14. So we apply the values here. X naught value is 1 and x1 is 2, x2 is 7 and x3 is 8, and corresponding f of x value, that means f of x naught value is 1 and f of x naught comma x1 4, f of x naught comma x1 comma x2 minus 2 by 3, f of x naught x1 x2 x3 is 1 by 14. So we substitute the values in Newton's divided difference. We get f of x is equal to 1 by 42 into 3x cube minus 58x square plus 321x minus 224. Now we calculate the value of f of 6. So we substitute x is equal to 6. We get f of 6 is equal to 6.23809. And next problem. Find the function f of x from the following table. Hence evaluate f of z. Here x values varies from 0, 1, 2, 4, 5, 7 and f of x is 0, 0, minus 12, 0, 600, 600, 7308. Here the given data given value is 6. So we assume the polynomial to be of degree is 5. So since f of 0, the given corresponding value x is equal to 0, we get the function f of x is also 0, and x value is 1, we get the function f of x also 0. So f of 1 is equal to 0, and also x value is 4, corresponding f of x value is 0, so f of 4 is equal to 0. It's clear x into x minus 1 into x minus 4 is a factor of f of x. So let f of x is equal to x into x minus 1 into x minus 4 into pi of x, where pi of x is the generator of the polynomial. So first we find the function pi of x. So polynomial pi of x. So pi of x is equal to f of x divided by x into x minus 1 into x minus 4. So first we calculate x value 257. So we apply x is equal to 2. We get pi of 2 is equal to f of 2 divided by 2 into 2 minus 1 1, 2 minus 4 minus 2. So we get minus 12 divided by minus 4 is equal to 3. And pi of 5 is equal to f of 5 divided by 5 into 4 into 1. So we get 600 divided by 20, 30. So next we apply x is equal to 7. So pi of 7 is equal to f of 7 divided by 7 into 6 into 3. So we get 7308 divided by 126 is equal to 58. Now we form a Newton's divided difference table. X pi of x, del pi of x and del square pi of x. So x value is 257 and corresponding pi of x values we get 330 and 58. Now we find del pi of x. So 30 minus 3 divided by 5 minus 2 is equal to 27 divided by 3 is equal to 9, and 58 minus 30 divided by 7 minus 5 is equal to 28 by 2 is equal to 14. Next del square pi of x. 14 minus 9 divided by 7 minus 2 is equal to 5 divided by 5 is equal to 1. So now we apply the formula, Newton's formula. Pi of x is equal to pi of x naught plus x minus x naught into f of pi of x naught comma x1 plus x minus x1 into pi of x naught x1 x2. So we apply pi of x naught is 3. So 3 plus x minus x naught value is 2. So x minus 2 into pi of x naught comma x1 value is 9. So 9 plus x minus 2, x minus 5 into 1. So we get x square plus 2x minus 5. So the pi of x value is x square plus 2x minus 5. So we apply the function f of x. We get f of x is equal to x into x minus 1 into x minus 4 into x square plus 2x minus 5. Next problem. Find the divided difference of f of x is equal to given function f of x is equal to x square plus x plus 2 for the arguments, and corresponding the x value is 1, 3, 6, 11. So we use the function and the x value. We form a Newton's divided difference table. Given value x value is 1, 3, 6, 11 and f of x function is x cube plus x plus 2. Now we substitute x is equal to 1 in the function f of x. We get 1 cube is 1. So 1 plus 1 plus 2 we get 4. And next we substitute x is equal to 3. We get 3 cube plus 3 plus 2. So 32. Next we apply x is equal to 6. We get 6 cube plus 6 plus 2 is equal to 224. Next x is equal to 11. So 11 cube plus 11 plus 2 is equal to 1344. Next we find del f of x. So 32 minus 4 divided by 3 minus 1 is equal to 28 by 2 is equal to 14. 224 minus 32 divided by 6 minus 3 is equal to 64. 1344 minus 224 divided by 11 minus 6 is equal to 224. Next 64 minus 14 divided by 6 minus 1 is equal to 10. 224 minus 64 divided by 11 minus 3 is equal to 20. So these are the Newton's divided difference formula. Thank you.